In this video, we are going to do problem 9 and 10. Problem 9 asks us to simplify this expression, square root of b squared minus 4 times a times c, when a is 4, b is 4, and c is minus 7. That's one problem. And then a separate problem. There are parts here. You're doing the exact same work. You're plugging in a, b, and c into this expression, but here the numbers for a, b, and c are different. So question number 9 has these 4 parts. It's actually 4 separate questions. Question 10 looks a lot different, simplifying this expression, but I want us to do them together because these two skills are needed when we use the quadratic formula. Let's go ahead and do 9a together right now. All right, so the directions are fairly straightforward. Everywhere you see an A, you're putting in a 4. Everywhere you see a B, you're putting in a 4. And everywhere you're seeing a C, you're putting in a minus 7. Now, plugging it in and simplifying can be difficult. Let's just go for it, and then I'll model a strategy if you're having a hard time simplifying. Square root of b squared, square root of 4 squared, minus 4 times a is 4, times c is minus 7. 4 squared is 16, minus 4 times 4 is 16, times a minus 7, 16 times a negative, 16 times a negative 7, it's still not right, 16 times, how come I can't, there, I cleared it out. 16 times 7, and this calculator is weird where I have to hit the negative sign after. That was the mistake I was making. It's minus 112. So we have minus 112. Minus a minus is plus. We have 16 plus 112. Which is 128. And now I want to think about what perfect squares will divide in evenly to 128, right? So back here to our perfect square list, I'm looking for a perfect square that divides in evenly to 128. I'm going to try 16, looks pretty good to me. 128 divided by 16 is 8. Excellent. So 128 is 16 times 8. Square root of 16 times the square root of 8. Square root of 16 is 4. And the square root of 8, clearly I didn't get the largest perfect square factor that divided into 128 because 8 has a perfect square in it. It has 4. 8 is 4 times 2. Using my product property, square root of 4 times the square root of 2. The square root of 4 is 2. Square root of 2 is just square root of 2. I'm left with 4 times 2 times the square root of 2. 4 times 2 is 8, so we've got 8 root 2. All right? Now, some common mistakes for people to do. One is to just say, to actually simplify right away here and say, oh, the square root of b squared is b. But we cannot take roots across terms, only across products and quotients, only multiplication and division, not addition or subtraction. And so, like, if you did do that mistake, right here on this step, people sometimes would be like, oh, I'm excited, I see a 16, and 16 is a perfect square. 4. You can't do that. And in fact, if you're always going to notice a perfect square right there because the formula has a perfect square showing up right here. Another mistake that's difficult for people is when we're doing subtraction, and my answer here, my product right there ended up being negative. So doing that minus a minus is plus is a common mistake for a lot of students. So if you are having a difficult time plugging in here, you could write this and put parentheses around all your inputs. B squared, I'm going to write that way, minus 4 times A times C. And even taking it a step further, if I write my formula, if that subtraction is a place where you're getting hung up, I can write minus 4 times A times C as plus a negative 4 times A times C. And this helps a lot of people plugging in with those parentheses and doing the plus right there. That makes simplifying a lot easier. Let's go ahead and put in 9A, put our answer in, see how we did. All right, so we only did A together. I'm going to leave B, C, and D for you. So our answer was 8 times the square root of 2. 8, I'm going to use my arrow, square root 2, save, submit, and it's saying, are you sure you want to leave those blank? Yeah. And we did great on the one that we did. All right, so the concept is the same. You're just plugging in these numbers for those letters and simplifying. Question 10 is different, but we're going to do it right now because it's helpful when we're doing the quadratic formula. All right, so this is problem number 10. And when I'm looking at the square root of 48, I'm thinking to myself, a perfect square probably divides in evenly to 48. Like 4 should go in there at the very least. 48 divided by 4 is 12. Oh, there's another 4 there. I'll bet you 16 goes in here. 48 divided by 16 is 3. Excellent. So just on that piece alone, 48 is 16 times 3. All right, so we've got, I'm not even thinking about the rest of this, 10 plus the square root of 16. I already got ahead of myself. The square root of 16 times 3 is the square root of 16 times the square root of 3. Just using that product property. Now the square root of 16 is 4. Square root of 3 is just square root of 3 all over 10. And it's super, super common for students to just simplify that square root of 48. Just simplify here and stop. Okay? But we don't want to stop because we really have a fraction here and we have a common factor in my numerator and my denominator. Excuse me. So I see, when I look at 10, 4, and 10, I see that they all have a 2 in them. 2 times 5 gives me 10. 2 times 2 would give me 4. So 2 times 2 square root of 3 would give me 4 root 3. And 10 is 2 times 5. Yeah? I'm not canceling 2's. I'm really acknowledging this times 1 right here. And this seems like a nice enough place to stop. If we're wanting to write it as one fraction. But I also, remember DD, division by my denominator, this is also 5/5 plus 2 root 3 over 5, right? If I went back in this direction, my denominators are the same, so what do? I add my numerators. And the only reason why that seems appealing to me is because 5 over 5 is 1. So we could also say 1 plus 2 root 3 all over 5. And this seems like a really nice answer as well. I'm interested if the text will accept them both. Hopefully it does. Okay. If you liked this, you may have wanted to start there right away. Notice DD division by my denominator. This is 10/10 plus 4 root 3 over 10. 10/10 is 1. And 4 and 10 have that common factor of 2. 4 is 2 times 2. And 10 is 2 times 5. So there you see another 1. We get 1 plus 2 root 3 over 5. Yeah? So let's go ahead and put both of these answers in. This is good. This is good too. Sorry, I have the sniffles. All right, so I want my big fraction bar. And let's see if I can zoom in. That's better. My big fraction bar, up in my numerator, I want 5 plus 2 times the square root of 3. And in my denominator, I want a 5. Save. Looks beautiful. 5 plus 2 times the square root of 3 divided by 5. Submit. Excellent. So that answer was accepted. Let's see if the other simplification is good. So that one's 1 plus, now this fraction, in the numerator, 2 times the square root of 3. And in the denominator, a 5. Save. Looks good to me. 1 plus 2 root 3 over 5. Excellent. So it likes both those answers. All right. The key thing here, though, is you needed to, it's two things. You needed to simplify that square root of 48. Right, so that got us down here, and then this is the common place to stop. But I see that common factor of 2 in each of these, so I needed to factor it out to acknowledge that little times 1. All right, so that concludes this video.